Welcome to a new test and teardown video. This time it's another one of those AC voltmeters, but I will call this DR for Danish Radio because it's written here in this engraving. I'll try and put in a picture of this in a much better quality. I can't really read the letters under the DR logo they tried to make. Maybe this is just a secret engraving to mark this item as being property of a Danish radio. But I really don't know. Maybe this was ordered or made by them or something like that, because there is no other names or numbers anywhere written on this unit, and everything here, as you can see, is written in Danish, and they engraved, this is a thick aluminium front plate, and they engraved the text like that, or CNC milled it in there, and then they painted and put in black and red paint into the grooves. It's really an amazing front plate. What else can we say about this? I have no clue how old it is, but I guess 1960, something like that. Is probably full of tubes or whatever. It's really heavy, and as you can see, quite big, obviously. And you turn it on by activating one of the ranges, and you turn it off by pushing that one. This releases any of the ranges, and this means switch off. And we of course got this nice meter in millivolts and in decibels, so all that is pretty nice. And this means the left one means effective. It's probably RMS, and this is peak. And then we got fast and slow. So that has, of course, something to do with the meter response. The input here can be unsymmetric or symmetric, and in symmetric mode, they're using this connector, rather weird connector, but this I think is the old analog connector system, and it says here no DC voltage and maximum 25 volt AC, and that is of course because there's an input transformer, and the output, there's of course an output amplifier in here with 600 ohms, and then there's this unsymmetric input 1 mega ohm into the first amplifier, I guess. Yeah, and we got some filters. So I think this is full range, 10 Hz to 1 MHz. Then this audio range, and then I don't know exactly what CCIR range is for, but this is obviously a standard of some sort of filter range thingies. And the cool thing is, if you're in the audio range and you have your reading, and if you push the full range here, and then you see your meter goes up, then you know that there is some nasty stuff going on outside of the normal audio range, and then you probably need to do something about it. So there is a really nice user feature for this, but we better open and inspect a little bit before we do anything else. No markings, no numbers, nothing. So this is a very boring rear side, but I think I see some tubes in there. So at least we are inside. We got some circuit boards in here as well, full of tubes, and there's, funny enough, another one down there. And here we got a big hefty transformer. I expect maybe some capacitors. That will be all the filters and good stuff around that. No, those are transformers, audio transformers. Mains transformer is hidden right there. I need to go and dust this off outside with some compressed air so we can see what is written down here. All the dust collected right there. I can't even see what's going on really, but I do see a problem. So this rectifier is completely blown up and cracked and all that. And then, so this is the mains entry cable going to the first switch. And then mains goes via those two fuses. One is missing. So this is intentional to prevent. No, it is not. Look at that. This is the voltage selection. By moving the fuses, so in case you don't read the text and understand what is going on, you could potentially put in two fuses or something like that. Oi. What is that for a voltage selector thingy? So it's amazing what a little bit of compressed air and a paintbrush can do. So now it's nice and shiny. I'm already starting to do a little fuse repair. They're always completely corroded. But I have already learned exactly what this is, and that is so cool. First of all, the RV-55 is, of course, a Röhren voltmeter. And of course, if you look at all the components, they're all from Siemens, West Germany, all of them. And there's like a lot of stuff indicating a German brand. And then, if we flip this a little bit around, here is the Sennheiser logo. And then this unit we see here, that is indeed the Sennheiser RV-55 tube AC voltmeter. More or less exactly as it is. And then the front plate is some sort of special design, but it is done in a quality level I haven't seen in a long time. Definitely a super top pro company did this, because everything here is done to a very high standard. I mean, look at the milling job and the wires, all the mechanic parts. They even found the same kind of spacers. It is just amazing what they have done. Oh, look at that detail here. They didn't even make holes in the front for all this. No. Those are welded into the front and then screwed in. That is pro. Oh, it's the same with all the screws for the switches in there. Look at that. Look at the nuts here on the back. See? No screws at the front. We are definitely talking about some pro dudes. No amateurs can do stuff like this. How amazing is that? And everything looks quite all right. This looks like a leaked capacitor. You can see this. And that is probably one of the reasons why we have this melted down, blown up capacitor. We also got this. I mean, what is going on here? They're supposed to touch each other like this. The positive side of this touches the metal like that. This is probably also a good reason for a problem I need to look into. yeah. So I will definitely get started. I will put in some link in the description to some of the different models I've found on the internet, and then you can easily find much more information about the Sennheiser. And they also, I also found a Grundy and the HB one. So yeah, this unit here is sold under many different names. So here is the rectifier. We can even read the name on it. It's not... I'm not going to repair this one. You can definitely see the little problem here. I also tried to move those two capacitors. They're connected to ground and to chassis. They could have moved these closer. But then here is a capacitor that somehow got mixed up. So it's supposed to be not touching that one. And you can see what happens when this one falls down due to vibrations and whatnot. Then it's going to touch the other one. That is not too good. And then there is this down there. It looks like leakage or some stuff is exploded in there. So I need to go and have a look in there and maybe remove this board somehow. All those switches, they are connected directly to that board, and we got a lot of wires going on here. So I'm not super funny about that, but that is the way if I am ever going to fix this. But first of all, I need to go and get the schematic. That was super easy. Now I know exactly what it is. So plenty of sites share some schematics, so I should be able to figure out what's going on here. I took some really nice close-up pictures of all the wires, so what is what here in the different colors, and then I can go and look up the data sheet of this one and then figure out what is what here and how the wires they were mounted here, because otherwise I wouldn't have a clue. So here is the pinout of my selenium rectifier, B30C400. So it's 30 volts and 400 milliamps. So of course a low voltage and rather low current. So I figured out this has something to do with filaments, but we got quite a lot of tubes. So this can't be for all the tubes. So I think we need to look a little bit more at the schematic. So here is the schematic of the full unit. If we zoom in a little bit on the bottom center part, we see the rectifier GL2. That is our selenium rectifier, and it drives 4 filaments or 4 tubes in series, tube 4-3 and then 2-1. And if we look a little bit up again and see the full schematic, we can see the tube 1 is the EF184. There is a dotted line around this tube 1 section, and that is because that tube is on a separate circuit board. Then we go to tube 2. This is a PCC88 triode. It's a dual triode, so that means tube 2 actually exists 2 places in the schematic, and then that means there's actually 2 filaments inside this tube, and they're connected in either a series or parallel inside the tube. What do we know? They only got 1 set of connections out of this tube as far as I remember. The thing is that those 2 tubes, they are in series, and this is a 300 milliamp filament tube, and this is the same thing with tube 1. So those two tubes in series, that will be 13 volts. And now we can look at again and see at tube 3 and tube 4. It is exactly the same thing that is going on here. Again, the same two tubes, and exactly the same two things is happening here, right? So if we now zoom down on the rectifier and capacitor section of the schematic, we will see a rather important error in the schematic, and that is the voltage. So they have written down 13 volts across C33. That is of course the voltage of filament 1 and 2 in series. But now look at something funny. The voltage on C32, they are writing 36 volts. This cannot be true, because 13 and 13, that is 26. And no matter how careful we look at this 36, I can never make this into a number 2. So this is definitely a calculating error or writing error or something like that. So this is what I need to recreate with my new and modern rectifier that I put in instead of this selenium, because I'm not putting in a new selenium rectifier. I will put in a silicium rectifier, and then I will slowly crank up the mains voltage while I will monitor the voltage on C32, and then I will of course stop at exactly 26, and then we will have the correct voltage on all our 4 tubes here. So here I have located C32 and C33, and this is the capacitor I want to monitor when I'm powering up everything. Of course I need to put in my new rectifier, but that should be fairly easy. So to test this, I now put in the 26 volts from a DC supply just to see what is going on with my 4 tubes. And here is the thing. The current is very close to the 300 milliamps I was expecting. And if I turn off the light, I can also see I got the filaments going on here. It's difficult to show, but they should be, yes, this one as well, and this one as well. Yeah, come on, baby. And down here is tube 1. And of course, those 2 wires that goes right there, the 2 thin wires that goes down to the first circuit board, that will be the filament voltage. And since this one is the last one in the series connection, I should be able to measure the DC voltage on this point to ground. And look at that. We are very, very close to 6.3 volts. So there's definitely something to it about the 26 volts. So I am now monitoring the filament voltage and the high voltage. It should be able to regulate the high voltage to about 200 volt. I turned this on, and now I will plug in my mains and crank it up real slow from 0. And what I see immediately is I get a little bit of voltage, and that seems to be pretty good. What I'm aiming for is 26. So this will be 100 volts input. It's using 10 volts here, and I see this is the filament voltage. Everything is good, and we should start to see some high voltage. So the high voltage is coming. and this is 200. Why is the meter hammering up like that? And then I have 220 volts input. We got 26.8, so I should probably crank down the input voltage a little bit, and I can easily do that because I can monitor. I got my 200 volts regulated, and that will be my 26 volt filament voltage. And of course I need to adjust everything, but let's wait a little bit and see if it goes to 0. So this is my 0. Everything here is of course open. Maybe it is a little bit sensitive. It's using 42 watts at the moment, and I'm quite happy about the high voltage is also nice and stable. What happens if I go to the other ranges? Of course this is the background noise from this open chassis. So there's a little bit adjuster here for 0. Oh, that's interesting. So this is the peak and effective, fast and slow. I better go and find some signals and plug in and see if it's working. This is, yeah, pretty good so far. To be honest, I've actually been searching a little bit for a good reason to have this wireless display for the walls. This is actually pretty sexy. So now I can put it somewhere where I can neatly monitor the voltage easier, and this way I can maybe zoom in actually even more on the readouts here, and then we can see it's a little bit low. This is 250 millivolts RMS at 1 kilohertz, and I am using that filter right here. And if I take the other filter, I get exactly the same readout. You also got this CCIR, and it's a different curve. So let's go back to the 30 hertz to 15 kilohertz, and let's play with that. So if I give this 5 kilohertz, yes I did, and that is the same. And then let's crank it up, 6, 7, 10, and then it should start to decrease. That is 15, and I expect it to go fast from here, 16, 17, 18, 19, 20, and then it's gone. So that is 20 kilohertz, and if I go to this one, should go from 10 hertz to 1 megahertz. And then we are back. And let's try 50 kilo, 100 kilo, 500 kilo, and 1 megahertz. Okay, let's try 1 point. Okay. Okay, and there it starts to go down. That is 2 megahertz. Now it's 2 megahertz. And then it goes down 2.6783 megahertz, and it's 10 dB down or something like that, right? All right. So that is a pretty good 100 kilohertz again. And we are very close to 0, and it should have been 250, something like that. So I will try and see if I can find the different adjustments and see if I can fix this there. That could be pretty good. So look at that. I have now adjusted the unit for very close to 250. But now comes the fun thing. So let's hold the camera right here, and then let's try and change this to 300. Look at that. So that's a problem. That we got a gain issue, not an offset. And then if I go to 200, here we go. See? we need more gain somewhere in the system. So I'm not done adjusting. So yeah, this one here is only the offset. This one is not the gain. And the thing is, this annoying schematic that I got is not telling me exactly which one of the trimmers in here in the circuit board is doing what and where are they located. So I need to follow the tracks to this tube and follow that to that and trying to figure out what is what anyway. But I'm not going to bore you with the next 2 days of playing around with the trimmers and all that kind of stuff. I just wanted to show this cool little AC voltmeter that turned out to be a Sennheiser. And yeah, I think I got it more or less up and running with a new rectifier, and wasn't that bad. So thank you very much for watching. Hope to see you soon again. Bye.